Example 2 is another new type of question. I have a name for it. I call these ones multi-revolution questions. And the reason for that is if we think, what does that 3 do inside of a function? If you were graphing this, what would that 3 do to the sine graph? It wouldn't change the amplitude. It's your b value. So what does the b value change? Your period. In this case, your period would be 2 pi over 3. With our transformations unit, that means that we have a horizontal compression by a factor of 1/3. When we have that horizontal compression by a factor of 1/3, what it does is it makes between 0 and 2 pi have 3 complete periods instead of 1. So I call it a multi-revolution question because we are going to have to go 3 times around our circle instead of once around our circle. The reason for that is looking at its domain. So with these multi-revolution questions, and the multi-revolution questions are when you have a horizontal compression or stretch inside. If our original domain, in this case for part A, is between 0 and 2 pi, if one x is between 0 and 2 pi, then 3 x's, which is what we have in between, is between 0 and 6 pi. Does that make sense? If I got you to guess a number, not guess a number, to pick a number between 0 and 10, so you do that in your head, and then I said multiply it by 3, now everybody's numbers could be between 0 and 30. You started between 0 and 10, but when you multiplied by 3, they could now be between 0 and 30. So if x is between 0 and 2 pi, then 3 x's would be between 0 and 6 pi. The reason we do this is, you know how, like I showed you that question with the, I believe it was the tides, and it had like the 0.16 pi, and we solved it with our graphing calculator, but then I showed you how to solve it algebraically, and we temporarily made theta equal to 0.16 pi t. A similar thing happens here, except we don't even have to make the theta equals. If you were solving this, I'm just going to write this temporarily with theta. If you were solving this, what would you say? Your next step, you would say, is that on your unit circle? Yes. When is your y coordinate equal to 0? Okay, now we're in radians, so make sure you say your answer in radians. 0, pi, and 2 pi. That's what you would say, right? You would solve it and say 0, pi, and 2 pi. But we don't have theta there. What do we have this time? We have 3x. So what will I write here instead of theta? 3x. And the reason we call this a multi-revolution question is if you're solving for 3x, 3x isn't between 0 and 2 pi. 3x's have to be between 0 and 6 pi. And how many times around our circle is 0 to 6 pi? 1, 2, 3 full times around. In the first time around, you hit 0, pi, and 2 pi. In the second time around, you're also going to hit 3 pi and 4 pi. And in the third time around, you're going to hit 5 pi and 6 pi. Ooh, and I just noticed something. Small detail that is slightly different than most of the examples we've done before. And I think I've warned you about this in the past with your textbook. Do you notice the textbook has 0 less than or equal to x less than 2 pi? Ooh, and what did I write? 0 less than or equal to x less than or equal to 2 pi. So I have to go and take a tiny eraser and erase this part. And then when I multiply everything by 3, I'd have to take a tiny eraser and erase this part. And because 6 pi isn't included, I have to take out a big eraser and take out the 6 pi because it's not included. Ugh. Tricky. So always check your domain while you're doing your question. Check it at the end too. Always do a double check on your domain because it's easy to just go between 0 and 2 pi and include things and then find out later something wasn't included, and in this case it affected it. Now, when a question says solve, what do you think they want us to solve for? X. Did we solve for x? No. We solved for 3x. So we're not done yet. If you wanted to solve for x, if 3x equaled pi, what would you do? Divide by 3. So in these questions, to find our final answer, we've got all of our answers between 0 and 6 pi, because that's what 3x's are between. And when I divide each of these answers by 3, well, 0 would still be 0, but this will be pi over 3, 2 pi over 3. I know I can simplify this, but just for 3 pi over 3, 4 pi over 3, and 5 pi over 3. And when you divide all of those answers by 3, look at our final answers. All of our final answers are between 0 and 2 pi. So with a multi-revolution question, you find out what does that 3x do? How does it affect your domain? It's now between 0 and 6 pi, 3 times around, instead of 0 to 2 pi. And then when you divide by 3, you get all of these answers. Okay? So, do you want to know what this looks like graphically? I'll quickly, don't draw this down, but I'll quickly show you graphically what just happened. And it might make sense. I'm going to mark 2 pi right there. I'm going to go up to 1, down to -1. I'm going to graph y equals sine of 3x. The period would be 2 pi over 3. So if I think from 0 to 2 pi over 3 would be right there. I divide that into 4 equal sections. Another 2 pi over 3 would get me to 4 pi over 3. I imagine dividing that into 4 equal sections and dividing this into 4 equal sections. And my sine graph would go from middle to max to middle to min to middle to max to middle to min to middle to max to middle to min to middle. Oh man. To middle. There we go. And so it would look like this. And if we found out where it was equal to 0, how many answers would we have? 1, 2, 3, 4, 5, 6. We almost have 7, but this one wasn't included in the domain. Yes? If they wanted you to graph it exactly, and they said between 0 and 2 pi, yes, you'd have a closed circle there and an open circle here to say that that point wasn't included. So technically, that's how you could graph included points and not included points. Yes? Well, what we did is before this looked like this, okay? Before it was stretched by a factor of third, we would have had all of this graph. If I just graph sine theta, and I'll use theta, I'll even draw it in green, because remember how I wrote theta in green at the beginning of this question? Okay? If you solve for theta, well, you know that sine of theta looks like this, right? And if you went to 6 pi, it would have another to 4 pi and to 6 pi. Today is sound effects like crazy, right? So if you solve for theta, well, theta would just be here. Yes. Would just be that part. But when we said, well, theta is actually 3x's, and 3x's would mean you'd have to solve between 0 and 6 pi, that's where you got all those answers. And when you divide by 3, that's when this gets squished. Oh, I want to see if I can squish it. Yes. Oh, it doesn't squish it as nice as I wanted it to. I just wanted to squish it this way. But when we divide that by 3 and do the horizontal compression, this whole part between 0 and 6 pi gets pushed back into between 0 and 2 pi. So we found these 5 answers first, 6 answers first, and then when we applied the compression, they became those 6 answers between 0 and 2 pi. Okay? So to recap, what we noticed was if we want to solve for x between 0 and 2 pi, and we first solved for 3x, which is what we did. We first solved for 3x. Well, 3x's we'd have to look between 0 and 6 pi. And then when we divide by 3, all of those answers between 0 and 6 pi become answers between 0 and 2 pi. Part B. Part B can be done in 2 different ways, but right now I'm just going to show you one way. Okay? It's not as elegant as the second way, but for what we've done so far, Part B says state the general solution. If we're reminded of how we've done the general solution and what we wrote down for our notes for general solution, we said to do the general solution, solve like normal from 0 to 2 pi. In this case, you'd be solving like normal for a multi-revolution question, which is not normal for you yet because you haven't practiced it very much, between 0 and 2 pi. And then once you get your answers, you add 2k pi to all of them. So we'll go back to what we were doing. Have we solved between 0 and 2 pi? Yes. What can we do next? We can take all of our answers. So for part B, I'll just do it on here, separate page. For part B, to write the general solution, x equals. You take all of the answers you've written so far. So that was 0, pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. And technically, if you had normally solved it between 0 and 2 pi, you would have included 6 pi over 3. But can you see that 6 pi over 3 is coterminal with 0? That's like 0 and 2 pi. They already end in the same place. So the general solution, yes? You could write that as pi if you'd like, yeah. Yeah, 3 pi over 3 is equal to pi. No, you have to go plus 2k pi on each of them. That's what we're going to do. But you only have to say k is an integer once. So later I'll show you the more elegant way if you'd like, but this is the way that we're going to start with. Okay? Question you can do for this one is number 10.